Hey everybody, it's Mrs. Bianchi. We're looking at number 10. Based on the equation 481 divided by 7 and 4/10 equals 65, which equations are true? Choose all the correct answers. So a couple things to consider. One is, let's write our example over here. All right, so if we were to switch these two things out, the quotient and the divisor, reverse them. In other words, put the 4 over here and the 3 over here, and then write the rest of it, which is 12 divided by, is this still a true statement? So 12 divided by 3 equals 4, but does 12 divided by 4 equals 3? That would be a yes. So what we need to look for is we need to look for an option that maybe has this and this reversed. So in other words, the 7 and 4/10 in the quotient position and the 65 in the divisor position, keeping this number the same. So if that's a choice, then you should go ahead and pick that. All right, now you do have to pick more than one. So let's talk about another strategy that you might use to find the one that would be correct. So if it's true that if we were to take this number and multiply it by this number and it would give us this number, then that means that we should also find others. If you're not good at dividing to see if the statement is true, how about we try multiplying? So let's say you think it's choice A, right? Wouldn't this number times this number have to equal this number? So if we do the check and we take this number and we multiply it by this number, here we get the 20. Here we get 35 and 2 more is 37. Here we get the 0 and the 3 more makes 3. Put a 0 to hold our place. Erase our old renamings or cross them out, whatever you prefer. 6 times 4 would give us the 24. This times this would be 42, and the 2 more would make 44. And this times 0 would be 0, plus this would be 4. Now, if we add these things up, here we get 0, 11, 7 and 1 more makes 8, and this makes 4. All right, but we kind of knew that we were going to be dealing with the digits 4, 8, and 1 because that's what we're dealing with across the board for every question. But where does the decimal go? So again, we're multiplying this times this to see if we get this. Now we would have to go over 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 to the left. Now, does this match this? What I have here in this yellow circle, does it match this number right here? It does not. So that means we're not going to pick that one. Now, of course, another strategy would be to go ahead and divide this divided by this to see if you get that. But just some other reminders of some other strategies you can use. So if you don't like the idea of checking to see if this times this equals this, and this times this equals this, and this times this equals this, then the other strategy would be the idea of just understanding about moving the decimal. So let's go back to this original equation. And knowing that that equals 65. Now in class we talked about how if you move the decimal the same number of positions, that it would not affect the quotient. So if we think of some examples of where we might put the decimal in this number. So if we move this decimal over 1 to the right, wouldn't that mean we'd have to move this decimal over 1 to the right? So if I rewrite that number 481 and think about where the decimal is right now, and I move that over 1 to the right, wouldn't that mean I have to add a 0? And if I move this over 1 to the right, doesn't that become 74? So is that a choice? Do you see this written exactly in the lineup? We don't, right? But you can keep going with that idea by either moving the decimal to the right or the left, because in class we talked about how you could even divide by a power of 10 and that would still keep the same quotient. So if we consider going the other way, now remember our original position of our decimal is here and here. So what if we go to the left? What if we go this way, to the left? 1 to the left puts the decimal in front of the 7. 1 to the left puts the decimal here. 48 and 1/10 divided by 74 hundredths. Is that a choice? Because there's a difference between 74 hundredths and 74. So look carefully at the choices, because remember, it would always end up equaling 65. Now, if what I'm saying to you doesn't make any sense, then I think you're better off just going ahead and either multiplying this times this to see if you get that, or just sticking with the division to see which one's true. All right, good luck finishing that up.